two examples for 3D meshing. So I will start with this. So this is the first screen you will see, 3D. You click next, and then you can select, say, laminar flow, add to the selected physics, transport of diluted species, add to the selected physics, and then click next arrow, select the type of study, and again just finish. So it will generate all the nodes. Now last time we looked at 2D curved microchannel geometry, so I am just going to import that in a 2D work plane, and then we can just extrude it to make it 3D. So at any model you want to like go from 2 to 3D, you can follow the similar procedure, and all of these primitives, pre-built shapes are here, so which you can use. So click on the work plane. Here you can define any plane. So let's just go with this default plane, and if I just say build selected, and then in this plane geometry I'll right click and say import, and browse. Now I should find that file. Okay, so COMSOL tutorial is here, then this is the folder I saved. Click G1. I saved this file earlier from the 2D geometry which we created last time. So I click open and import. Okay, so this is the 2D geometry, and now we can just extrude this by right clicking this geometry and click extrude. So the object to be extruded is here. If there are more objects, you can again add to this box, and all of the objects can be extruded to different heights or distances. Okay, so I'm just going to give, say, 0.2 and build all. That will give you the geometry. Now there are different mesh options. So first thing is you can always go with the default mesh. Okay, so and default mesh is adapted based on the physics you are trying to solve. So if I just say disable this, then the mesh is adapted for just for the concentration field which we are solving in the transport of diluted species. So now if I choose physics controlled mesh and say normal and build all, it is a coarse mesh with just 564 elements. And if I enable this now, and now I can just use the same settings, but now mesh will be adapted for fluid flow, and if you click build all, it will be a finer mesh. It's taking some time, probably need to choose more coarser settings.
So depending on the equations we are solving,
yeah,
it will recognize automatically, or is there another method?
Yeah.
Must be a heuristic method right now, because it doesn't know anything about the solution, or does it?
No, it doesn't know about the solution, but it knows usually with fluid flow we have boundary layers. So they have a boundary layer mesh along these edges, which we can see.
Equations it will know, right? The equations we selected is laminar flow.
Yes. So we're going to solve Navier-Stokes and continuity. So for the same settings, you can see now it's roughly 200,000 elements, and mesh is really fine, which you can always see, and you can always play with these settings to change the type of mesh. And other thing I want to show is once you have created mesh, you may want to visualize. Sorry? Yeah, that's what I'm going to show you. It's inside, and most of the time when you construct a 3D mesh, you may want to look at the cross-sectional views. How is the mesh from inside? So you can just right-click this and select this plot. Okay, and this will generate a 3D mesh plot. And for generating mesh plot, you don't need to solve the problem because mesh is already there. And in this there are different levels. So this is right now surface mesh is plotted, but you can select volume, so all the elements are now plotted, and then you can use this element filter where you can write logical expression to see the mesh at different planes or different points. For example, if I enable this filter and write expression, just show me the elements for x greater than 2, and then I say plot. Maybe I'll just see the YZ view. So now I think you can see a boundary layer along this edge. So there is boundary layer, and then the rest of is free tetrahedral, and you can also look at these settings by just going back here, selecting user controlled mesh, and it will show you what is built in right now with the default mesh. It contains boundary layer mesh, free tetrahedral mesh, and you can always change these settings by going to the boundary layer mesh and changing the number of layers that you want and the thickness of first layer, all these adjustment factors. So this is the default mesh part. So now say in this geometry, if I want to generate a sweep mesh, so I will just continue with the same example and add a new mesh to this. So I right click on the model and select mesh. Again it will be a default mesh, so you can select user control mesh, and then you can delete all these pre-built settings by right clicking and selecting delete. But most of the times default meshes are good. So if you want to just go with them and try, unless your problem is specific, you want very fine refinement along some edge or things like that. Okay. So now I want to create a sweep mesh. So the first node is a default size, a global size box, and then you can add, right click and add a free triangular mesh. Okay, so you can generate a triangular mesh on a face and then sweep it in the Z direction. So for this, for free triangular, I just selected this upper face, right click it, it will be added. Now in this I add a size which will govern, now this local node will govern the size mesh distribution on this node. So in this I'll choose, say, okay, just maybe fine. Okay, and with this just let us select it, build selected. So it has meshed the top face. Okay, that's my view. Okay, now even within this mesh, if you want a particular finer mesh along the edge, you can again right click this, add a size, and in this size, in the geometry entity level, just select an edge. Okay, and in this edge you can select, okay, let us select these curved edges by I have pressed the control and then selecting all this. Now right click, so these 4 edges are added, and in this you can customize. Say I want a maximum element size along these edges as, say, 0.02, very fine edge along these edge. And so now if you build selected, you can see you have locally refined the mesh along this curved path. Okay, so these kind of refinements you can do, and all these will be propagated in the Z direction when you sweep the mesh. So once it is done, then we just need to go back to this main mesh node, which is right now mesh 2, and now select swept mesh setting. Okay, so in this swept mesh, geometry entity level is remaining. You want to now mesh the remaining part, all the other faces and subdomain, In the source mesh, select this, right click. In the destination, we just going to select this bottom face, okay. And there are different methods, but you can leave them on automatic, and with this you can just and also you can right click and add distribution, how many elements you want along this in the Z direction. So default is 5, so let's just go with the 5 and say build all. So this is how your mesh looks like. So let me show you this, and then probably this will be a better view. So this is the triangular mesh. In a similar way, if you want to construct the mapped mesh, so you can again, let me also add in this another mesh. Now I want to do the same thing, so I'm just going to select user controlled mesh and delete all these pre-built nodes. Okay. Now instead of free triangular, we're going to select the mapped in the more operations. Again, the procedure is exactly same. So if I select this top face, add it here, and then give a distribution, okay. In the distribution, I will select these edges. This is my straight edges, so I'll select all these edges and give say number of, maybe even the curved edges I can select in the same, means depending upon what kind of, if you need a finer discretization, you can make it in a different group. But if I select all these and say give 30 elements along every edge, so I can do that, and then I will add another distribution for these two edges, so pressing Ctrl and right click, and now you can define the number of elements. I have defined 10, and now I want a finer mesh near these walls, so I'm going to go with this predefined distribution type, and in this I will again say 10, and element ratio is the maximum to minimum, and then you can select arithmetic or geometric, and then you can select symmetric distribution or reverse distribution, okay. So with this, let me click build selected. So because of this symmetric distribution and this element ratio, we have finer mesh, but why it is not?
On the first distribution, you haven't added the edges. Yeah.
Oh, okay. Thanks. Okay. So I forgot to add these edges. So 1, 2, 3, 4, 5, 6, 7, 8. Right click, and now if we add this, yeah. So now it is more orthogonal. Thank you. Okay. And now you can use the similar idea, sweep it along the Z direction. Okay. So this was a simple geometry case, and let me quickly show you a little complicated geometry. So let me start a new again 3D, and let's just add this one, or maybe just this. Next, stationary, click finish. Okay. So in this, now I have saved a 3-dimensional geometry, so I'm just going to import that one. It's one of our micro mixers geometry. So it's a rectangular channel, main channel, and then we have grooves here in the, which is extruded in the negative Z direction. So construction of this geometry is not tough. You can build these rectangular blocks, and then Again, using the same work plane, you can construct one of these curves using Bezier curves. Once you know the parameters, then you can use array features to construct from one curve to the rest of the 6 curves or whatever number of curves you want. And once you have selected all these curves, you can extrude it in the negative z direction. That's how we have generated this geometry. Okay.
For the basic parameters, how do you input them? Is it the same as the one that you calculate from your optimization?
Yes. So in this one, we have manually entered those parameters.
So you did not use a MATLAB file to generate that?
No, not in this case. So again, we have different options. So I will show you how to use different features. So let's go to mesh and make it user controlled. So right now this is the again default global size, and this is the free tetrahedral for all the domains. So now we're going to do it domain by domain. So I'm going to select, say, domain, and this first 2 domains, which is the rectangular part. So I'm going to right click and add this, and in this, okay, I'll add a size. Now this size is local node applied to these 2 domains, and it will override the global node settings. So let's just go with the normal and build selected. Okay, so because we have not selected fluid physics, it is giving you normal mesh, and you can always customize it by checking this and using these default parameters, like what is the maximum element size you want. What happened here? Okay, so where is that window gone? Okay, desktop. So I can always play with this sizes. Say I want a maximum element size of 0.5 and say build. So it will build this. Now again you can use subsequent refinements. So right now you have generated a normal mesh or with this customized mesh for this domain. Now say within this domain I want to refine my top face. So all you need to do is just right click this, add another size in the geometric level entity. You need to now select a face, so a boundary, and in this you can just add this boundary, right click, and then say customize. So for domain our maximum was 0.5, so let me give 0.25 here and build selected. So now we have a finer top face. Now if you want a further level of refinement, again right click this, add size. Say now you want this center edge on the top face to be more fine, so you can again go to this geometric entity level, select edge, and then select this central edge, right click, and then in this again you can go to custom and make it more fine by saying that okay, now give it 0.1, select. So now we have a, maybe I'll show this projection. So we have a finer mesh along this edge. Again you want to add one more level of refinement along these points. So just maybe select this point setting and then add this point, and you can go here and say okay, make it 0.02, build off, or let's make it more fine. So now if you look at overall, so we have done different levels of refinement, and especially this inlet points I usually refine in all the micro mixing simulation, because at the inlet you have this discontinuity in the concentration, you have 2 streams coming in. So now once you have generated this top source mesh, you can just sweep it and it will be propagated in the z direction, whatever with all these refinements, local edge refinements, local point refinements. So you can just right click and select sweep. Okay. this is not sweep. We have not matched. We have matched the full domain here. So we are not yet going to see the sweep mesh for this. So let me delete this. In the first case, what we are doing is we are trying to build it domain by domain. So we have done these first two domains. Now you can add another free tetrahedral. So right now we have added free tetrahedral for the top two rectangular domains. Now the remaining means now we are meshing the grooves. So in these grooves you can keep it this remaining, so it will mesh all the remaining grooves. And again you can do a similar thing, add a size feature and maybe select directly a finer, or you can customize it using this. So with this we have seen how to do it domain wise, like selecting a domain, refining it, choosing different domain, giving different mesh setting. Now how do we implement mapped mesh in this case? Okay, because now we have these different edges and the faces are not forming exactly a cubic, like 4 edges required for mapped mesh. So let us just, for the completeness, I generated this. So now full domain is generated, but now let's try the same example with mapped mesh quickly. So I'm going to go here and add a mesh. Okay. Now if you want to do mapped mesh, again it is similar what we have done in the previous case, but the complexity here is because of the grooves our lower face has additional edges. Okay, so if I define my top face as my source face, COMSOL won't mesh it using sweep mesh to the bottom rectangular face. So what you need to do is, maybe if I could show you using transparency is not very clear here, so let me see. No, I cannot see anything. Okay, so I need to select my rectangular channel bottom edges. Okay, but when you have lot of such grooves and edges, it is difficult to select these edges manually. So the most important feature I want to show you here is the definitions, where you can right click and use selections and show there are a lot of options where you can select boundary. So the one which is well suited for this case is this box. Okay, you can define a box and all the boundaries which are within this box are added to a selection. Okay, so in this case z is equal to 0 is the rectangular channel bottom plane, and we want to select that surface. So x minimum and x and y going from minus infinity to plus infinity. Now y you can select, say, going from minus 0.1 to plus 0.1. That way we will just going to consider this plane, the bottom rectangular cross section plane, and then in the output entities you can select entity inside box. So all the boundaries which are inside this box we can select. And
what happened if some boundaries are partly inside and partly outside? Like a vertical case.
no, they are not selected. Entirely inside. And I think there are different settings here which we can play with and accordingly adjust our this 3-dimensional box. So I think this selection is created. So now I'm going to again go make it a user controlled mesh, delete this tetrahedral default, and I'm going to add in the more operation a mapped mesh. But I cannot mesh this because it won't generate sweep mesh. So I'm going to select why it is is not showing this.
Surfaces or the domain?
Sorry?
Have you selected the plane?
I'm trying to select this lower rectangular surface plane, but yes, it has to be on. Yes, thank you. So now it will show you the. So in the map mesh, you can go and select that will appear in whatever you have defined in the selections. So you select this box, and then now you can define size. Okay, and in the size again you can customize. So if you go with predefined, say fine settings and generate, it's not so good again, because there are different options: calibrate for general physics or fluid dynamics. If you select, it will be a finer mesh. So you can see the number of elements change, but irrespective of this, you can always tune it by customizing it and say maximum element size to be say 0.2 and build selected. So you can control the level of fineness.
So did it select all those areas or boundaries of the group also? Because in this projection you don't see it.
No.
But it has selected.
Yeah, it has selected everything. So now it has selected the full bottom rectangular face, including the faces which intersect with the group boundary.
Right, but they are not separate faces. It's just treated as one face.
Yes. And now you can sweep it upwards to the top rectangular face.
What I'm wondering is, those groups, do they have boundary lines on the plane? Or is it just mapping without knowing those lines are there?
No. It knows those lines are there, and that's why we see this, like these curved kind of mesh here, right? Because
Is it possible to see only that plane from the other side?
Transparency is somehow not working. I tried this. Usually with this feature you should be able to see it, but no, I don't know, somehow this resolution or something. Yeah, could be. So, but let us just make it more fine by saying 0.1 build all. Okay, and now it's a like routine work of sweeping it in the other direction. So just right click and say sweep, and we just want to sweep along this rectangular part. So just select 1 and 2 domain, and source faces all these boundaries which you have matched. So select the box 1, and destination face is the top face here. So I select this, and then I'll just say build selected. So
the source bound, can you show how many elements there are in the source? The top diagram that you have.
like
the top square box, not that one.
this one?
The one that shows 7, 13, 16, 18.
Oh, this one? Okay.
How many elements are there? How many entities are there? Those are the only ones?
Yes. These are the only ones. And if you maybe it will be more clear if I go this way. And so, like right now it has shown this part, but if you select, so these are the different parts.
Oh, so there are more than.
Yes. So it just
so each one is treated as a different boundary. That's
yes.
what it's like.
Yes.
So there must be.
Yeah, possibly. Yes. So means the main message I want to convey is, even if it is a complicated geometry but a extruded geometry, then we can use mapped mesh. and means you can control and make it more uniform. So we have generated the sweep mesh for the mapped mesh for the rectangular domain. Similarly, you can generate for these grooves here again. So again, let us make a selection of these faces. Okay, so these faces again, you can in the right click selections, select a box, level is boundary, and then Z minimum. These faces are located at Z is equal to -0.2. So you can select a minimum value of 0.3 and a maximum value of 0.1, so that plane is within this box. And again, you can select entity inside this box. So now it is selecting only these faces. So it is a kind of your selection to the selection for the destination face. And now you can again right click and generate another sweep mesh for the grooves part, and in the selection same face we select, and now we're going to in the destination select our box 2, which is this face. And again, you can right click this and define the number of elements along the Z direction you want. So with the 5 we can just select this, and let us look at this. So right now it is taking only one element default. So let me add here, rebuild this. Okay. So any questions about this part? Did I miss anything? Yeah, just one point which I missed, and it was, I think, with respect to this triangular mesh. So you can have multiple meshes, and when you are solving a problem, you can select you want to solve problem with which mesh. So the only point which I forgot is this element growth rate. So how you want to, so say I have defined this local refinement at this point, as minimum element size of 0.01, and but the maximum element growth rate, how element size going to grow after this point, is still taking this value from the global node, which is based on this normal. So it is 1.5, but if you think your gradients are here and you want more like slowly elements to grow slowly along from this point onwards, so you can select this point and define this local growth element growth rate from this point onwards. So say if I can just say make it 1.01, like a very small value, and then say build selected or build all. So I think it's going to make a very fine, because it's kind of almost, oh, how does it look like? So it is, I think, too small a growth rate I've given, so maybe I'll just change it to 5. So depending upon gradients, you can use this element growth rate. If it is a like a very boundary layer type problem where you have gradients restricted to a region, then you may just want a very fine mesh along this edge, but you can give a higher growth rate so that in the middle you have larger elements. But so according to problem, you can control this, and also you can iteratively go towards a more efficient mesh.
So can you explain more about the map mesh? How you define it, map mesh?
For the same problem?
Yeah, just below this.
Yes. So in the mapped mesh, so this is the default global size, right? And then I selected, this is my rectangular channel, so I selected this bottom face of the rectangular channel and I selected it using this box selection feature, where I created a box and said all the boundaries which are inside this box are treated as a boundary selection.
So this selection is just one face? One face.
Yes.
So is it including the curved face, or it's just a whole rectangle? Or
Including the curved face.
It's not just, the side COMSOL, it's not just one face. All the faces
on the same plane? Okay.
That's why I said count, let's count how many there are.
Yes.
I thought there should be 26, but it looks like there are more. So it depends on how it broke that curve.
Because we have a, I think, center line also, which is making even two
So there
even
were
on.
13 multiplied by 2. That's why I expected at least 26 faces.
Right.
If it had more than that, that means during that
Some
part,
internal
that
boundaries
has
may be.
split into more than 2.
Okay.
So then you do sweep mesh. It's just from one plane
Yeah.
to another.
Yes. So we
both directions.
in both directions. Yes. So, but the other thing to note here is, if you define your top face as a source face, and then you want to sweep to the bottom face of this rectangular domain, you cannot do it because it doesn't conform. Right? You have only two edges. So the general rule here is your source face can have multiple faces, but your destination face for each domain should have one face. That's what they say in their manual also. Yeah. Right.
So if you have like a groove on the other side of the rectangular, so can you do this kind of treatment to sweep? So you have same
grooves here?
Identical
Yeah,
grooves
yeah.
on the other side. In principle, you should be able to.
Yes, we should be able to do
But
that.
according to their rule, you won't be able to do that. Because
No, then what I will do, I will make a mid plane in this geometry. In the rectangular, make a mid plane. I will make that as my source face, and then generate both upside and downside using that source mesh. Possibly, or use these two top and bottom faces and divide this rectangular domain in half, and then.
But you need to have a conformal mesh. If you do that, there will not be conformal. Right?
Okay, let us try if you want to do it quickly, but at the same time Dapo is here to present, so
Yeah, it's an interesting question, but maybe you should move to.
yeah, I think it can be done.
Each one
So
should try on their own.
so maybe what I'll do, I'll do this and maybe send you guys the link if you are interested.
Let's all play with that.
Okay, yeah, that is
Those
fine
who
too.
are curious
Okay.
can spend some time. That's how we internalize.
Yes.
By listening to it, we know what is possible. And then we internalize on ourselves, we need to do it.
Right. Okay. So I'll just stop this then.